Welcome to the Dynamic Programming series. Dynamic programming is one of the most important topics you will meet in coding interviews, especially at top product companies. Many of the highest-paying companies regularly ask DP questions, often as classic problems or clever variations of them. That is exactly why mastering DP can seriously improve your problem-solving and your interview performance. But before we solve a single problem, there is one thing you absolutely need to understand. Most people learn dynamic programming the wrong way. They immediately start drawing tables, filling matrices, memorizing transitions, and trying to remember which row or column to initialize first. That approach might help you solve one specific question, but it does not teach you how dynamic programming actually works. To truly understand DP, you need to start somewhere else. You need to start with recursion. This is the single most important idea in this entire course. Dynamic programming is simply recursion with memory. Think about a recursive function. It solves a problem by calling smaller versions of itself. Instead of solving a problem of size n, it may solve problems of size n-1 and n-2. The issue is that recursion often solves the same subproblems again and again. Dynamic programming fixes this. Instead of recomputing those subproblems, we simply store their answers and reuse them whenever they are needed again. That is all it really is. Recursion plus storage. Or in other words, dynamic programming is enhanced recursion. That is why throughout the series, we will always begin with the recursive solution. Only after we understand the recursive thinking will we move to memoization and finally tabulation. Trying to write tabulation first is like trying to build the roof of a house before constructing the foundation. The foundation is recursion. So how do you identify a dynamic programming problem? Not every problem needs DP. Fortunately, there are a couple of strong signals that usually tell us when it might be the right approach. The first signal is choice. Whenever a problem asks you to choose between multiple possibilities, recursion is usually involved. Take the classic knapsack problem. For every item, you have a decision. Should you include this item or should you skip it? Every item introduces a choice, and each choice creates another branch of computation. However, recursion alone does not guarantee dynamic programming. For that, there is one more ingredient. Those recursive calls must start solving the same subproblems multiple times. This property is called overlapping subproblems. Here is a simple intuition. If a recursive function makes only one recursive call, there is usually no overlapping work. But when it makes two or more recursive calls, there is a good chance different branches will solve the exact same subproblem. So here is a simple mental checklist. If the problem involves choices, think about recursion. If that recursion leads to repeated work, think about dynamic programming. The second signal is optimization. Most dynamic programming problems ask you to find the best possible answer. For example, maximum profit, minimum cost, largest value, longest sequence, shortest path. Whenever words like minimum, maximum, largest, smallest, or optimal appear in the problem statement, DP should definitely cross your mind. So to summarize, a problem is often a good candidate for dynamic programming if it involves making choices and it asks for an optimal answer. If you notice both, there is a very good chance DP can be applied. So how should we actually solve a DP problem? Here is the workflow we will follow throughout this entire course. Step 1. Write the recursive solution. Do not think about tables. Do not think about matrices. Do not think about memoization. Just solve the problem recursively. Once the recursive solution is correct, converting it into memoization is usually a very small change. You are simply adding a cache so previously computed answers can be reused. After memoization, converting that solution into tabulation becomes much easier because you already understand the dependency between the states. So the order is recursion, then memoization, then tabulation, not the other way around. Many tutorials begin directly with tabulation. They explain how to initialize the table, which rows to fill first, and which formula to use. That may help you reproduce one specific solution. But if the interviewer changes the problem even slightly, you are stuck, because you memorize the implementation instead of the logic. Our goal is different. We are going to learn how to derive the solution ourselves. Here is another interesting observation. Dynamic programming is not about learning hundreds of completely different problems. Instead, most interview questions are simply variations of a handful of fundamental patterns. For example, the 0-1 knapsack problem has many variations such as subset sum, equal sum partition, count of subsets, target sum, and minimum subset difference. Similarly, other core patterns like unbounded knapsack, longest common subsequence, longest increasing subsequence, matrix chain multiplication, grid DP, tree DP, Kadane's algorithm, and Fibonacci also have numerous variations. Once you truly understand the parent problem, solving its variations becomes much easier because the underlying idea stays the same. So instead of memorizing dozens of isolated problems, we will master the core patterns first. So now you know 3 important things. First, how to identify a dynamic programming problem. Second, the correct workflow for solving one. Recursion, then memoization, then tabulation. And finally, you understand that most DP interview questions are simply variations of a small set of fundamental patterns. In the next video, we will begin with the most important pattern of all, 0-1 knapsack. We will first build the recursive solution from scratch, then optimize it using memoization, and finally convert it into tabulation. By the end of this series, you will not only know how to solve dynamic programming problems, you will understand why those solutions work. Let us get started.